Very good. So yeah, we're just adding plus 1 to the power. So 2 plus 1 is 3, and we divide by that new power, and plus c. Okay. Alright, have a go at the next one. A little bit trickier. There's this thing called letting u equal to the thing inside the brackets. So this kind of eliminates any difficulty in terms of you might be integrating what's in the brackets and then outside the brackets, you're just making it one letter. So once you've made that stuff inside the brackets to one letter, we want to find the derivative of that. So the derivative of that is 1. Now, if you didn't do this in methods, I don't know if you did. You may be wondering why we're doing this. Sorry, we want to get dx by itself so we can substitute du in. So then we rearrange. And now we're going to substitute both this one and this one into the equation. So that's u substituted, and then dx equals du, like that. So that all matches up. So it's just the rule we just did. So add to the power, divide by the new power, plus c. Now because the original asked us to find dx, we need to substitute x back in. So u equals x plus 3. So we substitute that back in. And that's our final answer. So you can see the function inside the brackets, which is to a power. Is the derivative of that present? And if so, what is the derivative of that? U equal to the stuff inside the brackets. So that's step 1. We're going to find the derivative. Step 2. Derivative is opposite of the integral, so you minus a power and put the old power out the front. So the third step, you want to get what by itself in the chat. Anyone know? If you're paying attention to the last example. What do we want to get by itself? Yeah, I confused you. So we don't want to get du by itself. We want to get, someone else have another go, not du. Have a guess. We want to get dx by itself. Because we're going to substitute the dx stuff into there. Okay? So rearrange this. So dx we bring up the top and divide by the 6x. So some of you may have gotten on to what's going to happen now. So isolate dx. So now when we substitute in, what's going to happen? Any ideas? When we substitute in, so we substitute in this, and we substitute in this, so what's happened? Cancel. So the 6x will cancel out. Nice. So this is called when the derivative is present. So if the derivative is present, it's going to cancel out and eliminate the derivative. Pretty cool, hey? I don't know. And don't forget to sub in what u is equal to at the end. Sub in and then solve in terms of x. And don't forget the plus c. Okay? Alright, so first step, let u equal to the stuff inside the brackets. We then find the derivative. We then isolate for dx, yep. So it becomes du over 3. We then substitute that in. Okay, so let's pause here. We've got 0 and 1. The x value, right? Now we've changed all the x's to u's. We also have to change the 0 and the 1 to u values. So this is like an extra step. So when x equals 1, let's start with 0. When x equals 0, well, let's put it into here, u equals 5. When x equals 1, what's the answer? Plus 5. Yep, very good. So we've got the new limits, or the new domain. So u equals 5 and u equals 8. So we've got to put those new numbers on the integral sign, or the definite integral. The definite integrals from methods. So we're going to do the integration. We're going to put them in square brackets though. So add to the power, divide by the new power, and then we have 5 and 8. So these are the things we're going to substitute in for the u value. Today's goal is to actually look at this. So we've got this rule. We've got a similar situation here. But it's not just x by itself, there's a 3 and a 2. So we've got to follow those steps, those 4 steps that I did before. Now this is an indefinite, so we don't have to worry about that substituting numbers in at the end. Okay, so we're going to let u equal to 3x plus 2. Again, we're going to find the derivative. I probably should have said, so there's no brackets and power this time, but it's 1 over all of that stuff. So it's more or less the same as all of that stuff down the bottom to the power of -1. So it kind of is in a power, or it is, but it's just hidden. Okay, and now that we've got no extra stuff like coefficients or numbers at the end, we can just use that rule in the learning goal. So ln x plus c, like that. And don't forget, we have a constant here. So it's more or less the same as bringing this constant out the front here. And then substitute in the u value.